Today, I'm going to discuss to you about limits. Now, one of the most basic and fundamental ideas of calculus is limits. And in fact, two of the major formal definitions of calculus depends on limits, just like the definition of derivative and also the definition of integral. Okay, so let's start here with the geometric interpretation of limits. Look at these three diagrams. Okay, we recall in our previous discussion, we discussed about tangent line problem. This is where the limit concept started. In the first diagram, for example, suppose we have a function y is equal to f of x and the graph of the function is this one. It's like a parabola opening upward, so we can assume that this is the graph of the function y is equal to x squared. Okay, so as you can see, the 2 points P and Q that lie on the graph of y is equal to f of x, okay, are emphasized in this diagram. Now from these 2 points, we can form a line, and this is the line, this blue line is what we call the secant line, okay? And at a point P also, we can form another line, this line T, and this is what we call the tangent line. Okay, so what happened if we let point Q approaches to point P? What happened? In the second diagram, this point Q becomes closer to point P already. Okay, so we let point Q approaches to P as you can see also in this third diagram. What happened to the secant line? As you can see, as point Q approaches to point P, the secant line also approaches to the tangent line T. And take note that the point Q is at the right of P. Now what happened if the point Q is at the left of P? Okay, this one. Consider these three diagrams. Suppose the point Q is at the left of P. This one, and this one. What happened if we let point Q approaches to P? That is from the left of P. What's your observation? Any observation? Do you have any observation? Okay. As you can see, as point Q approaches to point P, okay, the secant line also approaches to the tangent line T. And take note that assuming here we know the formula for the slope of the secant line. So in other words, we can also find the formula of the slope of the tangent line, okay, by putting the limit of the function, okay, the limit of the function as x approaches to a certain value, okay. So in this example, again, as point Q approaches to P, whether from the right of P or from the left of P, the secant line approaches to the tangent line T. Okay? And the y values as x values approaches to this point, the y values approaches to a certain value also. Now, what do you call that value? Y value. Okay? That y value is what we call the limit of the function. Okay? Take note, the limit of the function. So to understand more on the concept of limit, we have this intuitive definition of a limit. So this is the definition. Suppose we are given a function f of x which is defined when x is near the number a. Okay, where a is also a value in the in the set of x values. This means that f is defined on some open interval that contains a, except possibly at a itself. Now look at this diagram. Okay, so in the diagram, suppose we have the graph of the y is equal to f of x. So suppose this is the graph of the function f of x, okay, which is defined on an open interval. This is the open interval that we are referring to, this one. This is the open interval. The graph of the function is defined on this interval, right? So for example, now the assumption that the value of a is inside the open interval. So suppose this is our a. Okay, this is our a. That is our a. Now we start. So for example, we let all the points in this interval. Suppose this is, we use this interval for example. Okay, this is our interval. For example, we let this point, or we let all the points closer to A, approaches to A, but not exactly to A. Okay? So we let this point, for example, this point approaches to the point A. So this one. So dito na siya. Now, if this is now our x value that is moving towards A, then there is a corresponding y value. Corresponding y value. Okay? So, this is the corresponding y value if this is our x value. Now, if we keep on moving this point here, approaching to A, for example, ito, so the corresponding y value is this. Okay? And so on. So for example, this is the point A here. Okay? As you can see, as x approaches to A, y value approaches to a certain value, right? This one. How about from the right? So for example, this point here. From this point, we let this point approaches to the point A from the right. So there we can find y value that corresponds to the x value. Okay, this is the y value. And that corresponds to what? So this corresponds here. That is the y value if this is our x. How about if this is our x? Because we assume that x approaches to this point A. So we can have the point, the y value, and the corresponding y value is this. Okay? And so on. So what have you noticed? What have you noticed? Letting the value of x from the left of A approaches to that value of A, okay, and also from the right, then the y values also approach to a certain value, and that is what we call L, that value L. Then that value L is what we call the limit of the given function. So we write that one in mathematical symbol, we write this as the limit of f of x as x approaches A is equal to L. Okay? That is the geometric interpretation of limit. And again, we read this one as the limit of f of x. The limit of f of x. This is the graph of our f of x as x approaches to a. So as x approaches to a from the right and x, okay, approaches to a from the left, then equals L. Then that L is what we call the limit of the given function. Okay? Okay. So moving on. Moving on. To fully understand the limit concept, I have here an example on finding the limit, okay? Finding the limit of, finding the limit of f of x. Suppose this is our f of x, okay? This is our f of x squared minus 1 over x minus 1, okay? Then we want to find the limit of this x squared minus 1 over x minus 1 as x approaches to 1. Then we are given already the limit which is equal to 2. What are we going to do is to verify if the limit of this function as x approaches to 1 is really equal to 2. Okay. So applying the definition of limit, we look at this one. Okay. We let x values approaches to 1. So we have to consider from the right of 1 and from the left of 1. So this is our 1. And we have from the right of 1. And also we have from the left of 1. Okay? So, since this one here is in the interval, as you can see in the interval 0, 1, open interval 0, 1, or any interval, let's say this interval, for example, that one, this interval. So we choose values in the open interval that is closer to 1 from the left and from the right. So we start from the right of 1. Suppose our value is 2. Okay? Now, if our value is 2, all we have to do is to substitute this value to the function x squared minus 1 over x minus 1. For example, 2 squared minus 1 over 2 minus 1. Okay, so this is equal to 4 minus 1, which is equal to 3 over 1. This is equal to 3. Right? So the function value, if x is equal to 2, is 3. Now, if x is equal to 1.5, the function value is 2.5. And if x is 1.1 and so on up to 1.001, the function value is 2.001. In other words, if we let the values of x approaches to 1, okay, this approaches to 1, then the y values approaches to what? It approaches to 2. Okay? Now, how about from the left of 1? From the left of 1, we start from 0, for example. Then if we substitute 0 here, so this will be 0 squared minus 1 over 0. We have negative 1 over negative 1, which is equal to 1. So the function value is 1 if x is 0. If x is 0.5, the function value is 1.5. And if x is 0.9 up to 0.999, then the function value is 1 approaches to 1.999. And if we keep on increasing this value, but not equal to 1, so we let this values approaches to 1, then the y values approaches to what? As you can see, it approaches to 2. Now take note, as x approaches to 1 from the right, then the y value approaches to 2, right? As x approaches um, as x approaches 1 from the left, the y values approaches to 2 also. So in other words, since hand side, the left hand side and the right hand side is equal to 2, therefore we can say that the limit of x squared minus 1 over x minus 1 as x approaches to 1 is equal to 2. That is using the numerical investigation. Okay? Okay. So let's have the second example. Let's investigate, sorry, let's investigate the behavior of the function f of x is equal to x squared minus x plus 2 for values of x near 2. The following table gives values of f of x for values of x close to 2 but not equal to 2. Okay, so here, again, we use table of values to determine the limit of the given function as x approaches to 2. So we use values very close to 2 from the left. Let's say 1.0, 1.5, 1.8, 1.9, 1.95 up to 1.999, which is close to 2, right? Because we want to have, we want to let the points from the left of 2, okay, very smaller number, okay, approaches to the value of 2 from the left. So this one, it approaches to 2. What happened to the function values? If x is 1.0 or 1, the function value is 2. And substituting these values, we come up with these values. As you can see, it approached to what value? It approached to 4. How about from the right of 2? From the right of 2, let's say 3, then the function value is 8, and so on. So we let this one approaches to 2, and notice that the function value approaches to 4. So what's your conclusion? Okay, what's your conclusion? Our conclusion, so look at this diagram. We let the values from the left of 2 approaches to 2 and from the right of 2 approaches to 2. Then these y values approaches to a certain value which is equal to 4. Okay, from here and from here. In other words, we can write that the limit of the function x squared minus x plus 2 as x approaches to 2 is equal to 4. So that's the limit of the given function. And limit of x squared minus x plus 2 as x approaches to 2 is equal to 4. So we were able to determine the limit of the given function using table of values or by numerical investigation. Okay? Okay. So for your exercises or as your assignment, okay, we have this. Do the exercises 1 and 2. Then if you have answers or questions related to these exercises, you can always comment it in the comment section or comment box. Okay? And I'm very happy and I'm very willing to read and to investigate your answers. I'm very willing to do that. If you have questions, just comment in the comment section or you can message me through Messenger or email me if you have my email address. Okay, so thank you so much and God bless.